Okay, Ganesh. Okay, yesterday I was just discussing about the Java literals. Literals. So literals is something that you will come across this word very often. So Java literals are just like constants. So simply we can say that literal is a constant that can be assigned to a variable in Java. So the examples are like any constant. If you want to represent any constant, or let us say that if you want to represent any data. The data can be a numeric data, or the data can be an alphabetic data, or the data can be a floating point data, or a data can be any single character data. Any data that you want to represent in Java, you will represent that data in the form of values. If you want to assign 1000 is a number. If you want to assign that to any data type, you will assign that 1000 to an identifier, right? The values that you are defining in the form of data, we call it as what? Literals. It's going to be it will act as a constant. For example, if you want to represent Ganesh is a name. It is an identity. It is a permanent identity. Ganesh is going to be a constant of particular student name, I can say. So here Ganesh is going to be a constant, or Ganesh is going to be a literal. If you want to represent Ganesh, I can simply represent it like this. String student name equal to Ganesh. So I can call this particular part. I can call this as literal. I can also call it as constant. I can also call it as value. Right. So this is an unique identity. It is representing a name, and the name is Ganesh. Right. Any data that you want to represent in Java, you can represent that in the form of literals. So literals is a constant that is assigned to a variable in a Java. So this is the variable. We can call this as a variable. We can also call this as an identifier. This is what we call it as data type. So that is what I have explained yesterday. I have just given a brief introduction about what are Java literals. So again, the Java literals are classified into four types. These are the four types. One is integral or integer literal group. Second one is floating point literals. Third one is Boolean literals. Fourth one is string literals. After completing this, we will talk about number systems in Java. After completing number systems, we will directly jump into the primitive data types. Right? So let's continue this topic. Okay. So Java literals are classified into four types. One is let us discuss about this first. Integral or integer literal group. Move it little. Okay. Let us discuss about this. See, let me tell you one thing. In Java, all the data can be represented according to its group. Example, if you want to represent a number, a specific number, if you think that the number is not going to have any fractional values or any decimal values or any floating point values, you think that the number is a perfect whole number which is not going to have any fractional values, right? You can represent that number under the integral or integer literal groups. So again, this integral or integer literal group is classified into four types. What are they? You can either use byte, you can use short, you can use int, you can use log. So each and every entity is categorized according to its size. You say if you talk about byte is going to represent a size, and short is going to represent a size, and integer is int is going to represent a size, and long is going to represent some size. We'll discuss about these sizes in future. But if you want to represent any whole number which has no fractional values, you want to represent a complete number without any fractional values, you can use any one of these data types. You can use either byte, short, integer, or long. But what should be used according to the value, that we will discuss that in the future. We will discuss that in the future. But if you want to represent any whole number, you can either use byte or short or int or long. For example, the whole numbers are like number 10, 20, 30, 40. The number which has no fractional values. All these numbers will fall under what? You can place all this number under one group. Then the name of the group is integral or integer literal group. This is one category, and the second category is you can also represent char data type. For example, if you want to place a particular data in the form of letter, you want to represent a letter, single letter, that is enclosed between that is enclosed in single quotations. For example, if you want to represent the character B with single quotation, that should be enclosed in single quotes. Any character, if you are enclosing any character in single quotes, any character, B is a character, C is a character, and F is a character, right? Any character, if you are enclosing that character in single quotes, right? You can use char data type, and again this char data type is falling under integral or integer literal group. Very simple. The observation is very simple. The conclusion is very simple. Integer literal group is used to present the complete whole number that has no fractional values. Fractional values or floating point values. Such numbers can be represented using the that are just shown up below. What are the data types? Byte, short, int, integer, long. So please be informed that the above data types could be used according to the size this is one such conclusion. And the second conclusion is, in addition, if you have any requirement to store, if you have any requirement to store any character, any single character enclosed in a single code, you will have to use char data type that is also falling under the integer literal. So the examples are very simple. By looking at the example, you can easily analyze byte per 1 equal to 100, short number 2 equal to 200, int price equal to 2000, long phone number equal to some number. So if you see that everything is a literal, every data is a literal or every data is a constant. Every data is going to use a particular data type that is falling under integral literal group. Integer literal group means in order to store this whole number data, you will have to either use byte, short, int or long. The complete whole number can be saved or complete whole number can be stored. The number which has no fractional values or which has no floating point values can be stored by using any one of these data types, byte, short, int or long, which is falling under integer literal group. As simple as that. Then what is the major difference between byte, short, int and long? We will discuss that. We are going to discuss that. But all these data types are falling under integer literal group category. Again, the literal is nothing but a constant. Every data, each and every value is going to be represented as a literal. You can also call it as constant. You can also call it as a value. Right? This part, the part that is after the equal to signature is called as literal. This is called as identifier. Number 1 is an identifier. Number 2 is an identifier. This is an identifier. This is an identifier. This is user defined identifier. This is called as a data type. All these together can be called as what? They can be placed under one group. The name of the group is integer literal group. As simple as that. And the last one is character. You want to represent, for example, if I say that if I want to, my initial is M, if I want to store my initial by choosing a data type, I can choose character data type. I can give an identifier like initial. So in this example, you can see the single character is stored by using a char data type. Enclosed in single quote. As simple as that. Right? So we have completed what is integer or integer literal group. Second one is floating point literals. All this each and every literal has some set of rules that you have to follow. So next thing is floating point literals. See why they have introduced a floating point literals is very simple. Sometimes if you want to store a value, store a data with high precision. For example, If you want to represent a temperature, or just for an example, if you want to represent the price of the petrol, if you want to represent the price of the petrol, to represent the price of the petrol price should be in such a precision that even if you are trying to use petrol, you will use petrol according to the rate that is displayed. The rate is displayed with high precision. What does it mean? They will also include paise. Along with the rupee, you will also you will also force to see the paise. Don't see petrol price is like 100 rupees or 101 rupees. No, usually the petrol prices will be shown with the highest precision. Means the price of the petrol can be 102.78, 102 rupees 78 paise. This is called as the complete precision. Not only petrol, if you want to represent the temperature, for example, I am living in Chennai, want to represent the temperature of Chennai. You cannot represent the temperature of Chennai without the fractional values or without the floating values. You cannot say the temperature of Chennai is 34 degrees Celsius. You can say like 34.72 degrees Celsius, something like that, with high precision. Hope you are able to understand. Not only this petrol prices or its temperatures, you want to represent speed, anything, if any data, if you want to represent with high precision, you have to go for floating point literals. Because the floating point literals will not ignore the fractional values. It will also consider the fractional values. If you want to look at your bank balance usually, it usually has the two decimal precisions. Your balance is, let us say, that 10,000 rupees. It won't display it like just 10,000 rupees. There will be like two additional precisions, two decimal placeholders. After points, there will be two additional extra placeholders, because paise will also be calculated. Paise may look, it may look a negligible amount, but if you consider the whole set of paises, you calculate whole set of paises, then the whole set of paises is going to make a big amount. If you want to calculate each and every paise for one single year, it is going to be a little more amount, little big amount. For one person, it could be big. For many accounts, for many bank persons' account details, if paises are ignored, then each and every paise is going to cost a lot of amount. That's why usually they don't ignore what paises. So to represent any floating point values, any floating point data, or any floating point constant, we use what? We use floating point literals. So floating point literals are classified into two types. One is float type. Any value, for example, price of the petrol 100.78. You need to specify it as F, because F is mandatory. F is like you are saying that it is a floating point literal. And the speed of your car, not 5.36. F. Price of milk packet price 38.15. F. F is representing the floating point value. So the second one is double. Double is also, it is also just to represent any data with fractional values, but it is going to have more placeholders, after the dot operator. So here we have included only two placeholders. So double is going to have more placeholders, but it could be like this, 222 point. A lot of placeholders will be there, and you do not have to specify it as F, because when you say F is for float. If you don't say anything, it is going to be for what? By default, it is going to be double. It is going to represent a little, a big number, big fractional values. It is going to represent a small fractional values. It is limited up to two placeholders, as simple as that. right? So the conclusion is very simple. This is also a constant. Floating point literals is also a constant. If you want to represent any data with high precision, order to represent any data with high precision, by just including the fractional part of a number along with the decimal point. Floating point literals are used to represent such numbers. Examples: the price of the petrol, the account balance, and the temperature. Anything, any data that is going to have the exact precision. So we need to use the floating point literals. Exact precision. Any data with exact precision, we need to use what floating point literals. So the real-time examples are like float petrol price equal to 102.35 F. F is mandatory here. F is mandatory. To be suffixed. You need to suffix. You need to ensure that you are suffixing. You are using the F at the end of the floating point literal, because the AVM is going to, if you are not suffixing it, it is going to consider it as the double value. Suffixing is very important here. Double any literal, if it has more than more fractional points, or so this is how the data can be represented by using the floating point literals. Very simple. Again, literals are nothing but constants. Are the constants, and if you want to use any kind of constants that are the data with high precision, you can go for floating point literals. And again, floating point literals are classified into float or and double. If you want to represent the price of the petrol, go for float. If you want to represent the speed of a car, any value that is going to have more than two decimal placeholders, two fractional placeholders, then you can go for double. So this is how the data can be represented by using floating point literals. We have so far completed two, integer or integral literal group. Now next one is Boolean literals. Boolean literals are very easy to be understood. So Boolean literals. Very simple. There are only two values that you can represent using Boolean literals. So the data type is Boolean. can represent true or false. These are the two sets of data that you can represent by using the Boolean data type. One is true, second one is false. When we talk about Boolean literals, it is going to say whether the condition is true or whether the condition is false. And if you want to define any conditions according to the value true and false, you need to go for Boolean data type. What is an example? Anything you can represent, it is going to say true or false. Boolean is empty. You want to ensure that something is empty or not empty, you can use Boolean literal. If it is empty, true. If it is not empty, false. We'll discuss each and every point in the future classes. So this is the literal. Just assume that these two are the literal or these two are the constant that can be saved by using the Boolean data type. And this can be anything. Is empty or contains anything. You can use any meaningful identifier. The output is going to be, when you have an output like true or false, if the output is a plain true or plain false, then go for Boolean literals. Use this literal to save this, to save the data which is true or false. As simple as that. The real-time example is like you will be using this types in many conditions. If you want to check any conditions real time, the output is evaluated in such a way that the evaluation results can contain either true or false. Apart from these two, that you cannot find any other result. Either you will find true or you will find false. In such cases, you will have to save that resultant value in a particular data type. The data type that you have to use is what? The Boolean data. Very simple to understand. True and false. That's it. Right? Making sense? Let me write some theory here. Any data that should be represented or evaluated to be represented in the form of two values. One is true, second one is false. Then we will have to use what? Boolean literals. The last one is we have what? String literals. This is very easy, string literals. What is a string? String is a sequence of letters or sequence of characters. When I say string, any sequence of characters. The characters can be alphabetic or alphanumeric or numeric or alphanumeric with special symbols. Anything that has a sequence of characters. For example, Ganesh. Ganesh is a name, but before even telling it as a name, you can also say that Ganesh is a sequence of characters that is enclosed in double quotes. In a sequence of characters that gets enclosed in double quotes. We call it as a string literal. So example Ganesh. Ganesh is a sequence of characters, string literal. And one more example is like 1, 2, 3, 4. Hello. Again, this is also called as a string literal because sequence of characters. It could be a numerical value or alphabetic value or alphanumeric value. You know, when it is getting enclosed in double quotes, we call it as string literal. This is also string literal. String literal. Sequence of characters. Alphanumerical with special symbols. Again, we call it as a string. Sequence of characters. I have included a space, but still everything is included in double quotations, double quotes, string. So the answer is very simple. When a sequence of characters that gets enclosed in double quotes, we call it as what? String literal. So we can say that to save any data that has a sequence of characters, we will have to use string literals. We will do a lot of manipulations by using string literals. As simple as that. So this is the typical conclusion for what? Typical conclusion for string literals. Single character means it is a single character. The differentiation is very, very simple. This single character, you use character data type only to represent a single character. It is a sequence of characters, string data. As simple as that. Examples: string student name Ganesh, string student location Chennai, string student address number second first street Tirunagar Chennai. Sequence of characters. No matter if you have included a space, if you have what included special characters, nothing. All these characters are in a sequence enclosed in double quotes. So we call it as what? String. Hope making sense. These are all about what? String literals. So the conclusion is very simple. There are 4 string literals. There are 4 literals in Java. So in Java, the values or literals are classified into 4 types: integer literal group, floating point literals, Boolean literals, and string literals. And again in integer, it is subcategorized into 4 types: byte, short, int, long. This is going to fall under one category: complete numerical values. And this is going to fall under one category: character. Character in the sense, if you want to specify any data that is getting enclosed in a single quote. Single character in a single quote, right? So we call it as what? Char data type. Char is a data type. Single character that gets enclosed in single quotations, right? And this is the explanation for integral, and we have the floating point literals, and again in the under the floating point literals We can say that if you want to store any data that has high precision, like petrol price of the petrol, or your account balance, the speed of the car, any such values if you want to save, you can go for floating point literals. Third one is we have Boolean literals. Boolean literals can be either true or false, and it has its own storage entity. Right, and the fourth one is very simple, string literals. String literals are any sequence of characters that gets enclosed in double quotes. Simple as that. These are the four Java literals. If anyone is asking what is a literal, literal is nothing but a constant. Literal is nothing but what? Literal is nothing but a constant or a value that is going to act as a data which can be stored by using a data type. As simple as that. Simply I can say that variable in Java, that is also data. That's it. As simple as that. We can conclude that these are the Java literals that you can come across in Java. These are the only literals that you can come across in Java. Right? Now the next topic is going to be number system. Number system topics is very important to understand the data types. Number system. Number systems in Java. So in Java, not only in Java, let us talk about the four prominent number systems that anyone can come across. The four prominent or the four important number systems that one has to know is, the first one is binary number system. Second one is octal number system. Third one is decimal number system. And the fourth one is we have hexadecimal number system. So these are the four prominent number systems that anyone can come across in any programming languages. The number systems are not specific to Java programming languages. There are many programming languages in the world. For each and every programming languages, understanding these number systems are very important, because we as humans, we understand the decimal number system. Decimal number systems are created for humans, and they are meant to be for humans. Decimal number systems, they are completely designed, or they are completely meant to be for the human beings. We understand the decimal number system. Why this binary number system, octal number system, why hexadecimal number systems are introduced? We need to we will understand that, and once after understanding that, understanding the primitive data types like integer, float, byte, short are going to be very easy, right? So little bit, there is going to be some theory little bit. After completing that theory, I will involve some concept through the practical examples, so that the understanding will be much better. So please be any numbers Programming languages. Number system. So in Java, the default number system is always the decimal number system is a default number system, but Java is also supporting the binary number system, the octal number system, the hexadecimal number system. We'll understand that one by one. By default, the number system in Java is decimal number system. So let us understand this one by one. Firstly, we will understand what is a decimal number system. Decimal number system. Any idea about what is decimal number system? Any idea about what is decimal number system? Okay, let me make it very simple. Let us say that I have a number. For example, I will just give you the introduction today. Tomorrow I will give you the clarity. So let us take this simple number 734. 734, right? How one can pronounce this? Pronouncing this number is very simple. It is 734. I can pronounce it like 734. This is how this can be pronounced. I am just writing it the way I pronounced. Right? 734 is nothing but 734. The way I pronounced, I am representing, I am just writing it the way I have just pronounced. I have pronounced it like what? 734. According to the pronunciation, I have written it as simple as that. 734. Right? Again, the 700 plus 30 plus 4 can be rewritten as what? 7 into 10 to the power of 2 plus 3 into 10 to the power of 1 plus 4 into 10 to the power of 0. Right? So this line can be rewritten like this. I can convert 700 like 700 can be converted as 7 into 10 to the power of 2. Both are same. But I am using a typical conversion. I am using a base 10 to convert it. Again 30 can be converted to 30 into 10 to the power of 1. Again I am using base 10. For each and every number, I am using a typical conversion where I am using the base 10. Right? Likewise, this is one example. A second example is, let us say that I have a number like 6594. Right? The way I pronounce it is like anyone who wants to pronounce this number, the pronunciation will be like 6594. This is the way it can be pronounced. 6594. 6594. Just use plus. Convert this with the base 10. Base 10 in the sense 6 into 10 to the power of, again the 6000 can be converted into 6 into 10 to the power of 3. And 500 can be converted into 5 into 10 to the power of 2. 90 can be converted into 9 into 10 to the power of 1. And this 4 can be converted into 4 into 10 to the power of 0. Both are same. This line is meaning, this line is going to be same as this line, but here I am using 10 to the power of base, 10 to the power of something. So I am converting everything into the base 10. So I am using it as 10. Right? So this is called as a decimal number system. So decimal number system, the base of the decimal number system is going to be what? 10. You cannot see it. If any number is written in the form of decimal number, the base is going to be always 10. Why it is going to be always 10? If you want to convert it with the help of base values, again you will get the same number. If you are converting it with 10 with some placeholders or with some place values, the number is going to be the same number by converting it with the help of the base 10. For example, if I have a number like 125, right? This 125 can be represented like this is a decimal number. Why it is a decimal number? The number that has base 10 is a decimal number. But you can ask me, there is no base 10 here. Even if you don't see, any decimal number is going to, the base of the decimal number is going to be 10 always. You see, you don't see, that is secondary. Usually we don't keep it as base 10. But if you don't keep, the base is always going to be 10. Why it is always going to be 10, we will understand now. 125 can be converted into 125. 100 plus 20 plus 5. Again, this 100 can be converted into 1 into 10 to the power of 2 plus 2 into 10 to the power of 1 plus 5 into 10 to the power of 0. Right? Again, the value answer is going to be what? 125. But the base that we are using is what? 10. That's why it is always going to be what? The base is always going to be 10. You split, you separate, and again you calculate, and again you use the power of 10 according to its place values. The number is going to be same. Whatever the number you take, if you say it is base 10, after the equivalent conversion, the number is going to be same. 125 is going to be 125. This is one way of representing, this is another way of representing. Right? So this is called as what? The decimal number system. So when you say decimal number system, the base of the decimal number system is always going to be 10. Why it is going to be 10? If you split the numbers according to your pronunciations, and if you do the further splitting with the help of the 10 to the power of placeholders. You say 100 in the sense take it, first placeholder is going to be 0, 1, 2. So it is going to be 10 to the power of 2. 20, 0, 1, 10 to the power of 1. 5, 1 is single digit number, so 0. That's why 10 to the power of 0. For after further evaluation with the power 10, with the base to the power of 10, the output is going to be the same. Another example I can take it like 4, 2, 4, 5, 6. Can be represented as what? 2456. Right? This can be again rewritten as 2 into 10 to the power of 3, 4 into 10 to the power of 2, 5 into 10 to the power of 1, 6 into 10 to the power of 0. Again, if you evaluate it, the output is going to be same. But why we are discussing, why we are doing this kind of evaluation? Just to tell you that the 10 to the power, we are using the 10 to the power. For each and every number that is splitted, each and every number is splitted accordingly to represent the 10 to the power of values. 2000 can be rewritten as 2 into 10 to the power of something. 400 can be written as 4 into 10 to the power of something. Likewise, 50 can be written as 10 to the power of something. Everything will be 10 to the power of something. That's why for decimal number system, the base is always going to be 10. What are the numbers that can use in the decimal number system? We can use numbers from 1 to 9. 1 to 9. These are the numbers. I'm sorry, 0 to 9. 0 to 9. These are the numbers that you can use in the decimal number system. We will discuss this further tomorrow. For the time being, just understand that This is how the decimal number. This is how the decimal number can be split and combined. Tomorrow I will be giving you the clear background. For the time being, just understand that the base number is 10 for the decimal number system. The base is power of 10 always. So digits will go from 0 to 9. The question can be, what is the base of the decimal number system? The base is 10. Right? For binary, the base is going to be 2. Why it is going to be 2, we will be discussing tomorrow. For octal, it is 8. For hexadecimal, it is going to be 16. For decimal, it is going to be 10. One by one, I will be introducing it from tomorrow. Please be available tomorrow. We will discuss about this further.